Greetings everyone, my name is Rijan Pabbi and I am an electronics engineering student from Netaji Subhash Institute of Technology, Delhi University. And today I am going to present you my 8085 project, which is Mathematical Alarm Clock. The Mathematical Alarm Clock is an embedded project which implements a special kind of alarm clock whose alarm can only be turned off after solving a mathematical problem presented to the user, hence the name mathematical. The logic board of mathematical alarm clock has various components. The main component here is the Intel 8085 microprocessor. It is the central processing unit for every peripheral IC on this board. It processes data from the I/O, ROM, RTC, and RAM inside the PPI. The next IC is the Maxim Integrated DS12887A, which is the RTC used in this project. This RTC comes in an eDIP package with a built-in battery and crystal. It also has an internal RAM of 128 bytes, which can be used for a non-volatile storage of variables or other things. Next is the 74537 address decoding latch. It takes the ALE input on the latch enable and helps in demultiplexing the address and the data bus of the Intel 8085 microprocessor. Next is the Intel 8155 PPI plus RAM plus timer. This IC was specifically made to be interfaced with Intel 8085. This IC has a peripheral interface with 3 ports. The third port has 6 pins and the other 2 have 8 pins. This IC primarily controls the LCD and the keypad array in our board. This IC also has a RAM which is 256 bytes long and is used as the primary RAM in this project. This IC incorporates a timer which we are not using but is very useful when needed. The next IC is the ROM. This IC stores the code for our 8085. It has 32 kilobytes of memory. The Intel microprocessor interfaces with this and reads every instruction line by line by fetching the instruction code from this IC. These 3 ICs are 74139 decoder, 7402 NOR gate, and 74138 demultiplexer. These are used to demultiplex signals, reading signals, writing signals, and other chip selects, and some usually small form of decoding logics. The top layer I/O board contains a buzzer for alarm, 20x4 LCD for displaying the time, the date, and the alarm time for the alarm clock. The next is the keypad. This numeric keypad is used for input for time set, alarm set, and the mathematical answer to the questions. These set of buttons are for programming mode. The programming mode has time set and alarm set. The next button is the reset. The reset button is used to reset the project into a no error state if an error occurs. The SID key is a testing key, but it can be used for other purposes. These 3 are the contrast, backlight, and brightness control. The toggle switch is to switch on backlight for the LCD. The potentiometers control the contrast and the brightness intensity for the LCD. As of now, this project is being powered from a USB cable and connected to a power bank. In future, it can be powered from a LiPo battery because it has all the provision for the circuitry required for a lithium ion battery. For now, I am going to power it from a power bank by connecting the USB cable in the USB connector. And here you can see that the time is 1754, which is
right now's time, and the date is 22/05/18, which is today's date. So I'm going to go to program to show you the alarm feature. Now I'm presented with the settings. It asks me if I want to set the time or the alarm, and I enter the choice. So I want to set the alarm. Then it asks me when I want to set the alarm. I put 17:55. Now the alarm is set for 17:55. Let's see if it sounds on 17:55. Okay, so now it's presenting me with a problem. I'm going to give the answer, and it has shut down the alarm. Now let's do it again. Program it for 17:56. So now we are presented with a problem, which is 1 plus 24. I am going to make a mistake here. Let's say 38. So now it's giving me 16 plus 17, which is actually 33. Let's give the right answer. And it shuts down the alarm. And there we go. It's a mathematical alarm clock which generates a mathematical problem when the alarm sounds, and functions normally as a alarm clock and a normal clock. So now I'm going to show you the time set feature. Let's set the time. I'm going to go to program and I'm going to set the time. Let's set the time to 9 a.m. So I'll put 0 and 9. And I want 9 a.m. so this is 0 and 0. So as you see, the time starts from 9:00 and 0 seconds. So I'll set the time to 9 a.m. The date doesn't change. The date only changes when the 24th hour switches over to the next day. In this project, I'm using big font on the LCD to make it look prettier. On a character LCD, you can generate characters as well as some custom shapes by storing it into the memory of the LCD. So that's what I've done with this project. I've stored some special shapes and I've printed them and made digits out of them, which are big digits. They are using 3 rows and 3 columns basically, and this effect is generated by that. Thank you so much for watching. Please leave a like, and thank you.